I'm going to show you how to dissect a sheep heart and identify the major structures. If this goes over 16 minutes, it's going to be split into 2 videos. That's just the way the camera works. The first thing you need is to get oriented. It's easy to find the apex, so you know the chamber with it is the left ventricle. The next thing you need to figure out is, are you looking at the anterior or posterior? The stuff at the top tends to be really squished, so that's not always easy to tell. This vessel right here is the only one that comes right up to the edge. That's going to be the pulmonary trunk, and that's on the anterior. So that tells you this is the right ventricle. So this is the anterior interventricular sulcus. The atria tend to be really flattened in these preserved specimens. So this is the left atrium. The flap portion of it is the auricle. Over here is the right atrium. Let's have a look at our large vessels. So we had the pulmonary trunk. If I put the probe down in it, that will go into the right ventricle. Directly behind it is the aorta. It looks like 2 separate vessels, but as you can see, the probe goes straight through. So one of these is a side branch, like a brachiocephalic trunk or something. I'm not actually sure which vessels the sheep has. And then behind that will be the superior vena cava. Notice that the wall is much thinner. And if you could feel this, you'd see it's a lot more flexible. And you see how it stays collapsed as well, while the aorta is staying open because the arteries have a much thicker wall. Inferior vena cava is not always findable. There we go. So it's often really squished. But now I've got the probe going through the superior, or in the superior, through the right atrium, and out the inferior vena cava. And then moving to the left, we have pulmonary veins. And usually these hearts, the veins are cut so short that you can't actually see 4 separate ones. You just have this big opening into the left atrium. So here on the posterior, right atrium, left ventricle, right ventricle, posterior interventricular sulcus, and along here is the coronary or atrioventricular sulcus. Okay. So it's really distinct here on the front left. It stops at the pulmonary trunk and then picks up again on the other side. Okay. The coronary vessels that you would find, they're not really distinguishable without having been injected with red and blue latex, but we can at least identify by location. So the left coronary artery would come out of the aorta across here, and then anterior interventricular artery comes down, and circumflex artery goes around in the sulcus. Left coronary artery stops at that branch point. It's like when there's a fork in the road and both of the forks, or both of the tines, get a new name. Circumflex comes around to the back and joins into the posterior interventricular artery. The right coronary artery would come out of the aorta and follow along the coronary sulcus here, and usually they both combine here to make the posterior interventricular artery. The veins, you would have the great cardiac vein along the anterior interventricular sulcus and then turning and following with the circumflex artery. across the back, you see where it's a little darker in here? Once we cut into the right atrium, I'm going to see if I can get the probe in there. That's the coronary sinus. Okay, so usually coronary means arteries, but then the coronary sinus is the large vein. It's called a sinus because that's Latin for bay, and we talk about veins as if they are rivers. The middle cardiac vein would be in the posterior interventricular sulcus, and the small cardiac vein would run along here and has some branches on the right ventricle. Okay. So that's everything we need to find from the outside. There are a couple of different ways that you can cut. I actually like to do the right and left side separately. It doesn't give you that lovely coronal section that you find in the textbooks, but it does get a nice neat look inside. I start at the pulmonary artery, and it's easier to do with scissors at first because it's so tough. But that'll take us into the right ventricle. I'm going to take this cut down, running parallel to the sulcus to make sure I stay on the right side. And then I go back up the back into the right atrium, and then this opens up. Here, oops. You can see the pulmonary semilunar valve, right where you go from ventricle to pulmonary trunk. Here's the wall of the right ventricle, and it looks like I've sliced into it a little bit. What we can't see from here is, get that out of there, the tricuspid valve. That's going to be visible back here where we get to the atrium. It's not always easy to tell that there are 3 flaps to it, but that's where it gets its name. And then it's got the little strings coming off it, chordae tendineae. And the papillary muscles aren't really distinct here, but they would be where the chordae tendineae attach. There's a little bit of a bump here. This little stretch, this is called the moderator band. It's for the electrical conductions, and that's found only on the right side. Okay. On the left, I'm going to start in the atrium and come down. The left ventricle is a lot thicker. Have to kind of work my way through it to get it to open up. I think I'm just going to go ahead and cut the atrium all the way open. Okay, so compare this wall to this one. Now, why is there a difference? Think about where they pump to. The right ventricle only has to send the blood to the lungs, which are right nearby, but the left ventricle has to send it to the whole body. This wall between them is the interventricular septum. Here we can see the chordae tendineae of the bicuspid valve, also known as the mitral valve, or left AV valve. And where my probe is going up behind that is where the left ventricle connects to the aorta. I'm going to need to do another cut to see the aortic valve. Just gonna, hold this open and cut a little further over here. Okay. There we go. So here's the connection into the aorta. That's the aortic valve. And that should be everything you need to know on the heart. I've cut into the septum a little bit here. Oh, the layers. So do you see how there's a different texture here, kind of a smooth sheet? That is the endocardium. All of this muscle is the myocardium. And then the outer surface is the epicardium. And that's actually the same as the visceral pericardium. The rest of the pericardium has been removed. If you had a sample with it, there would be a tough sac completely covering up to about here. And that's the fibrous pericardium. Attached to the inside of that is the parietal pericardium. And then parietal and visceral aren't actually attached. They have a thin layer of fluid between them, serous fluid, that allows them to rub against each other without causing friction. That is your sheep heart dissection.